In this section, we are going to graph linear equations. You also, in the section, have to tell if an equation is linear. So I've written down at the bottom examples of equations that are not linear. If you have anything that's squared, or any variable other than one, if there's any variable in a radical, if any variables are being multiplied together, or if there's more than two variables, or if a variable is in the denominator, that's not going to be linear. To put, if an equation is linear, you can put it in standard form. Standard form is ax plus by equals c, and there's no decimals or fractions in standard form. A cannot be negative, it has to be simplified. So if you want to pause this and read over it real quick, you can. So this question says, determine if the equation is linear. If it is, write it in standard form. Well, A is not going to be linear because X and Y are multiplied. So you would just say no. Now, in class, I'm usually going to want you to say why it's not linear. And you would just put because two variables are being multiplied. Sorry, my pen's going out. But you just write two variables are being multiplied. In the next equation, it says 3/4 x equals y plus 8. So is that linear? Well, it doesn't have any of the things that are not linear as I showed you in the first slide. So yes, this is linear. It's got an x and a y. And so we want to put it in standard form, which is ax plus by equals c. So I'm going to do that. I need to get the y on the left side of the equation. So first I'm just going to subtract the y from both sides. That's a y, not a 4. Okay, so I get 3/4 x minus y equals 8. Now, in standard form, you can't have any fractions or decimals. So the way that you get rid of the fraction is to multiply by the least common denominator, which is 4. So I'm going to multiply this entire equation by 4. So I get 12 over 4, which is 3x. Distribute your 4 all the way. So minus 4y equals 32. And that's it. This problem says graph each equation by using the x and the y intercepts. So how you do that, to find the x and the y intercepts, you just plug in zeros. So to find the x-intercept, plug a 0 in for y. To find the y-intercept, plug a 0 in for x. So for instance, in this problem, if I wanted to find the y-intercept, I would plug a 0 in for the x. And I would get 2 times 0 is 0, plus 4. So the y-intercept is 4. To find the x-intercept, I'll plug a 0 in for the y, so 0 equals 2x plus 4. Subtract the 4 from both sides. I'll get negative 4 equals 2x. Just divide both sides by 2. And I'll find my x-intercept was negative 2. So what I'm going to do is, let's see, I am going to graph this by plotting my y-intercept at 4 and my x-intercept at negative 2 and connect the dots. That's how you do that. All right, now the next one. You've got x plus y equals 4. So if I plug a 0, in for x, 0 plus y equals 4, I'm going to get y equals 4. And if I plug a 0 in for y, I get x plus 0 equals 4. So same thing, x equals 4. So both of my x and y intercepts are 4 in this case. So I'm going to go to where y equals 4 and where x equals 4. And I'm going to draw my line. That's how you do it. This last problem, I have graph 5x plus 3y equals 15 by using the x and y intercepts. So again, I'm just going to plug in zeros for the x and y separately. So 5 times 0 plus 3y equals 15. So it'd be 0 plus 3y equals 15. Divide both sides by 3. And you get y equals 5. Then if I want to do find the find the x-intercept, I'd plug a 0 in for the y. So 5x plus 0 equals 15. You get 5x equals 15. Divide both sides by 5. And you get x equals 3. So I'm going to plot both of those. So I've got, let's see, y equals 5 would be right here. And then x equals 3 right here. And then you just connect the dots. And that's it.